Hello students, welcome to Educate. In the last video, we have discussed till equilibrium constant from the Nernst equation. That means when during a chemical reactions, there be production of electricity. By a chemical reaction, there be production of electricity. Then what will be the relationship between electrochemical equilibrium constant, that means equilibrium constant of that cell, and the standard EMF of the cell. That means when during a reaction there be production of electricity, then what will be the relationship between equilibrium constant and the EMF of the cell. Now in this video we will discuss about the Gibbs free energy and the electrochemical cell, the relationship between the EMF of the cell and the Gibbs free energy. What is Gibbs free energy? So in thermodynamics of class 11th, you have studied about the Gibbs free energy, that is also called Gibbs energy or the free energy. As the name indicate, free energy means the amount of energy which can be converted into work, the maximum amount of energy which can be converted into work, that is called Gibbs free energy. And a process will take place if the value of Gibbs free energy, when the value of change in Gibbs free energy during a reaction will be negative. That means if the Gibbs free energy of product minus Gibbs free energy of reactant will be negative, then the process will be spontaneous. Also I am telling, okay, what is a spontaneous process? So a spontaneous process is the process for which there be no requirement of work. That means the process for which no work will be done, that will be called a spontaneous process. As for example, the falling of a stone or any object from greater height to lower height. That means, as for example, the falling of a stone from a mountain to the ground of the earth, or from a building to the surface of the earth, that will be called a spontaneous process, since during that process no work will be done. But if anyone have to keep a stone or any object from the surface of the earth to the top of a building, then he will have to do the work. As for example, you also know that water, if there is a water in the tank, at a building, there is a tank in which water is. There is a tank full of water at the top of a building. So if anyone will open his tap, then very easily the water will comes down to the tap. But if water will have to move from ground, that means from the surface to the tank, then he will have to start the motor. That means he will have to start the water pump. That is called, we usually called motor in our day-to-day life. So during that process, what happened? The motor, or that the water pump, that do the work, consume the electricity, and hence there be movement of water from the surface of the earth to the tank, to the water tank. That means the movement of water from higher altitude to the lower altitude is a spontaneous process. That means no work will be done during that process, and the movement of any object from lower altitude to higher altitude will be a spontaneous process. For that, work will have to do. Another example here, the movement of heat energy will be from hot body to cold body. If you will take water from freeze here, so heat energy here is cool, water will be cold than that of environment. The temperature of water will be less than that of environment. So heat energy will flow from environment to the water, and as a result the water will become hot. So movement of heat energy from environment to the water here will be a spontaneous process. And if we will keep a boiled water at the room, then after a certain time that water will become cool down. Why? Because heat energy will flow from that water to the environment. So during this case, the movement of heat energy will take place from water to the environment. So here it is a spontaneous process, and as a result the temperature of that water will decrease. So movement of heat energy from hot body to cold body is a spontaneous process. But if there is a water at room temperature and you will want more cold water, then what you do? You keep that water inside the freeze. Inside the freeze, the compressor works there, and that takes the heat energy from the water which you have kept and flow that heat to the surrounding. Here the movement of heat energy from cold body to hot body will have to do, and that's why there be requirement of work. In this case, the refrigerator do the work, and as a result the temperature of your water falls down and you get more chilled water. Okay, so that is a spontaneous process and non-spontaneous process. Same here in a chemical cell, the process will be, there will be a process will take place if delta G will be negative. That means there will be flow of electricity when delta G will be negative, and delta formula here is delta G equal to minus NF E standard, E standard of the cell. Here N is number of electron participated during the reaction, F is Faraday's constant whose value is 96,500 coulomb or 96,483 coulomb, whatever you would like to take, that much coulomb, and EMF of the cell, this one standard EMF of the cell. Put this formula in your mind, delta G standard equal to minus NF E standard, this one, and here not a standard, then simply delta G equal to minus NF E, and delta G standard will be equal to minus NF E standard. Here this one is delta G is negative, minus NF E standard, that indicates that delta G is negative. That means the process will be spontaneous. That means the production of electricity, that is here the movement of electron from anode to cathode will be a spontaneous process. That means for the movement of electron from anode to cathode, no requirement of work will be there, and the process will be spontaneous when delta G standard will be equal to minus NF E standard. Another formula you have studied, delta G standard, that is in chemical equilibrium, delta G standard that will be equal to minus RT log Kc or log K. It is here natural log. When you will have to convert it into log to the base 10, then you will have to multiply by 2.5. 2.303. So delta G standard equal to minus 2.303 RT log Kc. So if you know the value of Kc, you can find out delta G standard very easily. Or universal gas constant, if delta G standard you will calculate in joule, then R you will have to calculate in joule per Kelvin per mole. And value of R is 8.314 joule per Kelvin per mole. Temperature, usually we take room temperature 25 degrees Celsius, and here to convert into Kelvin, that will be 25 degrees Celsius, that will be added by 273.15 to Kelvin. So 298 here. 273 plus 25, 298, roughly that much. Log Kc. If you will have to find out Kc, if Kc, then 2.303 RT will come this side. So log Kc will be equal to delta G standard upon 2.303 RT. This you will calculate, and log 1 will come this side, that become anti-log. Here it is negative, so that will be Kc will be equal to here minus anti-log delta G standard upon 2.303 RT. That will be Kc. Kc will be equal to here, Kc when log will come this side, that will come minus anti-log here delta G standard, that upon 2.303 RT. That will be Kc. So if you will have to find out delta G and data will be given for Kc, then this one that means you apply, and if you will have to find out Kc and delta G is given, then this one you apply. Okay, let's see about this question. Question is, the standard electrode potential for Daniel cell is 1.1 volt. For Daniel cell, the standard electrode potential has been given. Delta G E standard. That has been given. Calculate the standard Gibbs energy for the reaction. Delta G for this one has been asked. Has been asking. So that means here E standard that has been given. The standard electrode potential of Daniel cell has been given. That is 1.1 volt. That has been given, and it is asking about the Gibbs free energy. Gibbs free energy, you already know delta G standard, that will be equal to minus NF E standard minus NF E standard of the cell. For the Daniel cell, E standard has been given and nothing given. That means this one is taking place at 20 room temperature. Here no required for the temperature also. This one, watch out about the reactions. One zinc atom have lost 2 electron and it converted into Zn2 plus. One Cu2 plus has gained 2 electron has converted into copper atom. So during this reaction, there is exchange of 2 electron. There is exchange of 2 electron. That means there is zinc have lost 2 electron which has been gained by Cu2 plus. So during this reaction, 2 electron has been involved. So that's why the value of N will be equal to 2. Faraday's constant, you already know, 96,500 coulomb or 96,483 coulomb, whatever you would like. For the simplicity, I have taken this one. I take this one. If you would like to take 96,400 coulomb, then also it's okay. And Gibbs, this has been given. So very simple here. This question is, so delta G standard will be equal to minus 2 into Faraday's constant, 96,483 if you want to take 483, if you will take 500, then you will get easier to solve the question. So during the 12th board examination, whatever you would like that to take, because there will be bigger difference in the values. But during the IIT main examination as well as in NEET examination, you should take 96,500 because you will feel easier to calculate. And in that examination, you may realize that what's the importance of 5 seconds, 10 seconds, 5 seconds, 10 seconds, 20 seconds. That will make here, if you will lose in all the questions, then how much difficulty you will face. So in the IIT main as well as in NEET examination, try to solve the questions in such a way that you take less time. Okay, so during the IIT main examination or in NEET examination or in IIT advanced also, on the presence constant you take 96,500. Yeah, I have taken 96,483 Kelvin because now you can use the calculator or you multiply there. There will be no scarcity of time in the 12th board examination. So here minus NF and E standard has been given 1.1 volt. 1.1 volt. Multiply this one. So its answer will be 21227 minus 21227, and here how much that is? What's about the unit? Faraday's constant here, Coulomb here. This one is in volt, and here and is number of electron here. So that is also this one. So finally the answer will be in joule per mole here. To convert it to 10 power 3 in kilojoule, because this value is very large. So you can convert them in kilojoule also. So to convert it into kilojoule, you can shift this one 21227 joule, and that much here, that will be the final answer. Okay, in kilojoule, 10 power 3 here you do, and here 10 power 3, so do this one like that. Okay, so very easy question that is. And this type of questions frequently asked in 12th board examination also, that will ask in 1 marks, and this one is also highly important for the NEET examination and IIT advanced, and more chances of asking this type of question in NEET examination compared to that of IIT main. But the importance in the IIT main should not be denied of this topic. Now let's see, just proceed the next topic. This question here, about this question, I just hint you the potential of hydrogen. So actually pH is given. So you should know for the question number 2.4, you should know pH is equal to minus log H plus ion, minus log concentration of H plus ion, that is pH. So concentration of H plus ion you can find out very easily, because this one concentration of H plus ion, this one will come at this side, minus anti-log pH is given 10. So 10 you can find out, and then after when you find out concentration of H plus ion, then electrode potential of hydrogen at that concentration you can find out. A standard electrode potential of hydrogen is 0. So here concentration of H plus ion you calculate and put the value of the concentration of H plus ion in the reaction, then you can find out a standard electrode potential of that means the electrode potential of hydrogen at that pH. Okay, very easy. Now second question here, 2.5, calculate EM of the cell in which the following reaction takes place. About the formula you already know that EM of the cell at any concentration, that will be equal to a standard EM of the cell minus 0.059 upon N log which get oxidized. Here oxidation is of nickel ion, so Ni concentration of Ni2 plus upon concentration of Ag plus, concentration of here, that will be equal to here, just I am writing firstly here. So EM of the cell at any concentration, that will be equal to a standard EM of the cell minus 0.059 upon 2 log concentration of which get oxidized, that is concentration of Ni2 plus upon which get reduced. Silver ion is getting reduced and stoichiometric coefficient is 2 here. So that will be 2 here. Here that N is 2 because 2 electron has been exchanged during this reaction. There is transfer of involvement of 2 electron in this reaction. That's why the value of N has been taken 2. Next question here is the cell in which the following reaction occurs. Fe3 plus is converted to I minus Fe2 plus Fe3 plus reacting this one, and so calculate the standard Gibbs energy and the equilibrium constant. Just let's say here what's the change in oxidation number here. and will be how much? You already know delta G standard equal to minus NF E standard. That is here. A standard of the cell has been given here. So N equal to how much? 2 Fe3 plus converted to Fe2 plus. 1 Fe3 plus converted to Fe2 plus. So 1 Fe3 plus has gained 1 electron, so that it has converted into Fe2 plus. So 2 Fe3 plus has been gained 2 electron. So here 2 electron here, and here also 1 iodide ion has lost 1 electron. So 2 iodide ion have loosened 2 electron. So the value of N will be also 2. So put the value here, N equal to 2. Very easily you could solve this question. N equal to this much, Faraday's constant, 96,500 coulomb, that is minus 2 here, 96,483 coulomb or 500 coulomb, whatever you would like, into EM of the cell 0.236. That much joule will be the answer. Okay guys, very easy to solve. In the next video we will discuss about conductance of electrolytic cell. Okay, and for this video it's all. If anyone would like to ask any questions, may ask in the comment box. Definitely I shall reply. Okay, thank you for watching my video. Thanks, Team Educate.